Hi, welcome to my second video in the playlist of Tamil Nadu State Syllabus Mathematics. Now, I kindly recommend you to watch the before video which I gave the overview of Unit 1, which is application of matrices and determinants. Now, in this video, I'm going to give a brief introduction on determinants. As I said earlier, my three basic questions will be what, why and how. So what, why and how. So in this video we will answer these three questions on determinants. So what is determinant and why we need determinant and how to find the determinant of a matrix. Now what is determinant? So how can you visualize determinant and why we need determinant? So first we are going to see what is determinant. Now you see that if A is a matrix, it's a 2 cross 2 matrix. A is a 2 cross 2 matrix. Why I am saying 2 cross 2 matrix is that I have two rows, which is AB is one row and CD is another row. Then I have two columns, which is AC is one column and BD is one column. So I have two rows and two columns. So I call this matrix as 2 cross 2 matrix. Now determinant of A will be determinant of ABCD, which is nothing but AD minus BC. So you just multiply the cross terms, which is AD, and the important thing is you want to put minus sign in between those two. So AD minus BC. So what it suggests? So what tells? So if I have a matrix A which is ABCD, then determinant of A is AD minus BC. So what can we infer from that, or how can you visualize this? Now for this you consider the row vectors. So the first row vector is A comma B and the second row vector is C comma D. Since it is a 2 cross 2 matrix, you should plot this in a two-dimensional plane, which is R2. So you see that consider the row vectors A comma B and C comma D. Now this is one vector and this is another vector. So I am plotting here. So look at this. So I am plotting the vector 1, which is V1 A comma B, and I am plotting the another vector which is V2 and A comma B. So இப்போ என்ன பண்ணியிருக்கேன் அப்படின்னா ரெண்டு வெக்டரையும் plot பண்ணியிருக்கேன். So next what I am going to do is I am going to make a parallelogram with the help of these two vectors. So I am going to construct a parallelogram with the help of these two vectors, and what I am going to do is I am going to calculate the area of this parallelogram. என்ன பண்ண போறேன் அப்படின்னா இந்த parallelogram ஓட ஏரியா கண்டுபிடிக்க போறேன். From elementary maths we know that the area of parallelogram is nothing but modulus of V1 cross V2. So this is the area of parallelogram. So again by elementary vector algebra, it is nothing but the cross product of two vectors. So which is mod V1 mod V2 sin theta, and we know that sin theta is square root of 1 minus cos square theta, and the angle between two vectors, I have used this formula to find angle between two vectors V1 dot V2 by mod V1 mod V2 whole square. So if I substitute V1 as A comma B, since a matrix A is A comma B and C comma D, I substitute V1 as A comma B and V2 as C comma D. So after simplifying, I get the value as AD minus BC. So what can we visualize from a determinant of a 2 cross 2 matrix? So நம்ம determinant of 2 cross 2 matrix நம்ம என்ன தெரிய வருது அப்படின்னா, the value of determinant of a 2 cross 2 matrix is the area of parallelogram made by the row vectors. So இந்த determinant value என்ன சொல்லுது அப்படின்னா இந்த parallelogram ஓட ஏரியாவை குறிக்குது. So this is how to visualize the determinant of a 2 cross 2 matrix. So this is very important. Determinant ஆன்சர் எப்படி வரும்னா ஒரு நம்பராக வரும். அந்த நம்பர் என்ன குறிக்குது அப்படின்னா இந்த parallelogram ஓட ஏரியாவை குறிக்குது. So the value of determinant of a 2 cross 2 matrix is the area of parallelogram made by the row vectors of this row vectors. Since I taken the row vectors a comma b and c comma d, it represents the area of parallelogram made by the row vectors. So this is what is determinant of a 2 cross 2 matrix. Now how can I visualize the determinant of a 3 cross 3 matrix? So how can I visualize the determinant of a 3 cross 3 matrix? Now this is the matrix A, which is A1, A2, A3, B1, B2, B3, C1, C2 and C3. This is a matrix A1, A2, A3, B1, B2, B3 and C2, C3, C3. So it represents the vectors in a 3-dimensional plane. So if a matrix is a 2 cross 2 matrix, it represents a vector in a 2-dimensional plane. So that's why I have only x-axis and the y-axis. But now I have a 3 cross 3 matrix. Since I have 3 rows and 3 columns, so determinant of A will be, first you take A1 and then omit the corresponding row and column, then you will be left with B2, B3, C2 and C3. And the second term you multiply it by minus. So minus A2 and then you omit the corresponding rows and column, you will have B1, C1 and B3 and C3. And for A3 similarly you omit the corresponding row and column, we have B1, B2 and C1 and C2. So how can we visualize this graphically? So again, if you calculate the determinant, we will end up with a number. So what that number tells? இப்போ நீங்கள் பார்த்தீங்க அப்படின்னா I'm just plotting the vectors. இங்கே நம்மளுக்கு B1 vector is A1, A2 and A3. B2 vector is B1, B2 and B3. And V3 vector is C1, C2 and C3. So I'm just plotting the vectors V1, V2 and V3 and I'm creating a parallelogram with the help of these 3 vectors. So you see that I'm creating a parallelogram with the help of these 3 vectors. And again, by the elementary mathematics, we know that the volume of parallelogram is the area of base plane made by V2 and V3 into height of perpendicular from B1 onto base plane. So again, if I substitute all these values in place of B1, B2, B3, I'll end up with the value of determinant of A. So from this what we can tell is the value of determinant of A of a 3 cross 3 matrix is the area of parallelogram made by the row vectors. So this is how we can visualize the determinant of a matrix. So the determinant of a 2 cross 2 matrix என்ன சொல்லுது அப்படின்னா parallelogram-ஓட ஏரியாவை சொல்லுது. and determinant of a 3 cross 3 matrix என்ன சொல்லுது அப்படின்னா parallelopipe-ஓட ஏரியாவை குறிக்குது. Now this is the first question which I answered, which is what is determinant. Now next I am going to answer why we need determinant. Why we need determinant. Now why we need determinant. Consider the linear equations x plus 2y is equal to 2, 2x plus 4y is equal to 4. So இப்போ நான் ரெண்டு ஈக்குவேஷன் வச்சுருக்கேன் x plus 2y is equal to 2, 2x plus 4y is equal to 4. Now why I am calling this as linear equation? நான் எதுக்கு இந்த ஈக்குவேஷன் linear சொல்கிறேன் அப்படின்னா we see that the highest power, the power of x, y is 1. So if that highest degree 1 இருந்ததுன்னா அது linear equation. Suppose if the highest degree 2 இருந்தது அப்படின்னா அது பேர் quadratic equation. Suppose if the highest degree 3 இருந்ததுன்னா அது பேர் cubic equation. இங்கே we have only the highest degree as 1. So we call these equations as a linear equation. Now I have a linear equation in 2 variables. So I have 2 variables which is x and y. So number of variables determines the plane. So here since it is a 2 variable, I want to plot this in a R2 plane, which is a 2-dimensional plane. Suppose if I have 3 variable, I should plot this in a 3-dimensional plane, which is x, y, z axis, which I have done here. So this is x axis, this is y axis, and this is z axis. So mark here, this is z axis, so this is x axis, and this is y axis. Now why we need determinant? Now we see that if an equation is a linear equation, then the graph will be a straight line. So this is a very important result. So we can able, again by elementary mathematics, we know how to plot a function. So first I'll take this equation x plus 2y is equal to 2, and I take the next equation which is 2x plus 4y is equal to 4. Now to find the points for the first equation, we want to find the x-intercept and the y-intercept. Now from equation 1, if x is equal to 0, then I have 2y is equal to 2, which is y is equal to 1. Now if y is equal to 0, then I have x is equal to 2. So the points are 0, 1 and 2, 0. So this is the points for the equation 1. And for equation 2, if x is equal to 0, then I have 2 into 0 is 0, 4y is equal to 4. Then I have 4y is equal to 1. If y is equal to 0, then I have 2x is equal to 4. Then I have x is equal to 2. So these are the points for the equation 2. Now you plot these points to find the graph. Now you see that 0, 1. So 0 will be here, 1 will be here, and 2, 0. So 2, 0 somewhere around here. So just mark, you just put a straight line. So this is a graph for the first equation, which is x plus 2y is equal to 2. And again you put the graph for the second equation, which is 0, 1, 2, 0, which is again the same. So what can we infer from this is that even though the equations are different, இப்போ நீங்கள் பார்த்தீங்க அப்படின்னா x plus 2y is equal to 2, 2x plus 4y is equal to 4, இந்த ரெண்டு ஈக்குவேஷனும் வேறு மாதிரி தெரிஞ்சாலும் ஆனால் அதோட கிராஃப் ஒரே மாதிரி தான் இருக்குது. So even though the two equations are different when we look, but the graph of these equations are same. So keep this concept in mind. Now we want to know what is meant by linearly independent and linearly dependent. Linearly independent and linearly dependent. So what is linearly independent? Suppose if I have two vectors a, b and c, d, and if this vector can be written with the help of this vector, then these two vectors are linearly independent. So if we can't able to write the one vector in terms of other, then they are called linearly independent. For example, consider the vector here. So I have vector 1, 2 and 2, 4. So 1, 2 and 2, 4. So what can you infer from this is that this equation can be converted, this vector can be converted to this vector by multiplying a certain number alpha. Then we say that these vectors are linearly dependent. Suppose if I can't find an alpha, then it is linearly independent. But when you look at this vector, suppose if I take alpha is equal to 2, then I can transform this vector to this vector. So what can we conclude from this is that these two vectors are linearly dependent. Now suppose if I take a vectors 1, 3 and 1, 4, now whatever may be the alpha, this 1, 3 cannot be transformed into 1, 4 by multiplying a suitable alpha. So we say that these two vectors are linearly independent. Now we can check easily if I have two vectors. But if I have a large vectors, suppose if I have 3 vectors or 4 vectors, then it is hard to verify whether the vectors are linearly independent or linearly dependent. So is there any method by which we can able to detect whether the vectors are linearly independent or linearly dependent? So determinants tells us the answer. that the vectors, whether the vectors are linearly dependent or linearly independent. So when you calculate the determinant for this matrix, so which is 2, 1, 2 and 2, 4, we get 4 minus 4 is equal to 0. So when the determinant is 0, the vectors are linearly dependent. If the determinant is not equal to 0, the vectors are linearly independent. So this is the main result. This is why we need determinant, because if you calculate with large number of vectors, suppose if you find the determinant, if you come to know that determinant is 0, so most of the vectors become redundant. Since it is same as another vector, so we can able to minimize the calculations required to find the solutions. So why we need determinant? To check whether the vectors are linearly dependent or linearly independent, we need to find the determinant. If determinant turns out to be 0, then the vectors are linearly dependent. If the determinant is not equal to 0, then the vectors are linearly independent. So again, ஒரு வெக்டரை இன்னொரு வெக்டராக எழுத முடிஞ்சுது, ஒரு சூட்டபிள் ஆல்ஃபா வச்சு எழுத முடிஞ்சுது அப்படின்னா இந்த வெக்டர்ஸ் ஆர் லீனியர்லி டிபெண்டன்ட். சப்போஸ் ஒரு வெக்டரை இன்னொரு வெக்டராக எழுத முடியலை அப்படின்னா the vectors are linearly independent. So we see that 1, 2 and 2, 4. 1, 2 can be transformed into 2, 4 by multiplying 2. So these two vectors are linearly dependent. So that's why the determinant value is 0 for this. Now when you look at this 1, 3 and 1, 4, determinant value is 1, 3, 1, 4, which is 4 minus 3, which is 1 not equal to 0. So that's why it is not linearly dependent. So therefore it is linearly independent. So can you visualize this for a 3 cross 3 matrix? Suppose if I have 3 equations with 3 unknown, then again we will find the determinant. If determinant turns out to be 0, then the vectors are linearly independent. So I have 3 vectors, either 2 of them are linearly dependent, or 3 of them may be linearly dependent, or 1 may be linearly dependent. But if determinant turns out to be 0, it is surely linearly dependent. But how many of the vectors are linearly dependent? I don't know. If the determinant is 0, the vectors are linearly dependent. Suppose if we have 3 vectors, for example, consider this. Let us consider the equation x plus 2y plus z is equal to 1, x plus 2y plus 3z is equal to 1, 2x plus 4y plus 2z is equal to 2. Now again, you just plot this in a 3-dimensional figure. You know how to plot a 3-dimensional surface. Now a 2-dimensional is a line, and for 3-dimensional we get a plane. So we need to find markings as 1, 2 and 3. Now again you take the first equation, you find the x-intercept, y-intercept and z-intercept. You first substitute x is equal to 0, y is equal to 0 and z is equal to, if you put x is equal to 0, y is equal to 0, then we have z is equal to 1. And if you put x is equal to, y is equal to 0, z is equal to 0, then I have y is equal to, x is equal to 1. Then if you put z is equal to, x is equal to 0, z is equal to 0 and calculate y, then I have y is equal to 1 by 2. So this is 0, 0, 1 and 1, 0, 0 and 0, 1 by 2, 0. So I plot this in a 3-dimensional figure. So this is x-axis, this is y-axis and z-axis. Now this is 0, 0, 1 is around somewhere around here, and some 1, 0, 0 somewhere around here, and this somewhere here. So this is the this area for the first curve. And again you find the plot the second equation, then we'll get something around like this or like this. So again you see that the first equation and second, third equation, when you plot this, I'll get the same answer. So we see that this is a multiple of 2. So by calculating determinant, if determinant turns out to be 0, 1, 2, 1, 1, 2, 3 and 2, 4, 2, if we calculate determinant for this, we will get 0. So from determinant equal to 0, we conclude that the vectors are linearly dependent. So we see that these two vectors are linearly dependent. So that's why we get a determinant value as 0. So I answered two questions, which is what is determinant and why we need determinant. In the next class, we begin with how to find a determinant of a matrix, and we will solve the exercise problems in 1.1. So main focus is not on solving the problem, but I want to clarify the concept that why we need and why we need to study, what is the use of it, etc. So I hope you enjoyed this video. We'll see you in the next video. Goodbye. Thank you for watching. Thank you.